Hello, I'm Lois Gray from North Highland College UHI, and in this video I'm going to show you how to simulate your VHDL test bench code using ModelSim PE Student Edition. So first of all, we need to find the ModelSim, which should be installed on your computer. Just move that out of the way. I've got a desktop access to that. If it's not in your desktop here, it will be down in your list of programs here. Just trying to find that ModelSim PE. Okay, so you can start it from there. You can start it from your desktop. Just click ModelSim, and we're assuming that you've followed the second video in this series and have already written your file for your half adder circuit. So you can see here's the half adder circuit. I'll just double click on that, show you the code so you can remember what it should look like. Okay, we're not going to go any further with that. So what we want to do is add our test bench, which we haven't yet written, to our project. So if you right click in the white area here, click add to project, new file. Of course, if you've already written it, you can add it from an existing file, but we're going to write a new file. I'm going to call it test bench. These you can just leave as they are, VHDL top level, that's fine. And you'll see it appears here with the question mark because it hasn't been compiled. So double click on that, double left click to open it, and then in here you will type the code. So you can get the code from the notes. This is for, I think, task 2. I've already copied and pasted the code, so I'm just going to, or copied the code, so I'm just going to paste it now. I'll quickly go through the code for you just to remind you how this works. This little box is a nuisance. Right, there we go. Right, let's put that full screen for the moment. So what we've got is our library, which is the IEEE library, and then we're going to use this one header file from the library, IEEE Standard Logic 1164, and we're going to use all of that. And then we need to set up an entity. All VHDL needs an entity and an architecture. But of course, because this is a test bench, it doesn't actually have a real component. It's just going to have an architecture. So we have an empty entity set up here. And then going on to the architecture, first of all, we call up what component we're going to be testing and define its inputs and outputs. So this should exactly match this part, the component that you had already built as your half adder. And then we also need to connect signals to the ports of this component. So this next section here is defining signals, because we can't simulate or we can't exercise ports on a component. We can only exercise signals. So we're going to connect these signals to these ports just by defining them here. You'll see we've also initialized the two inputs to 0, which is a good idea before you start simulating. Have everything in a known state. And so that's defining the signals, and in this next part, after the begin statement, we're what we're calling instantiating the component. So we're defining the component we're going to test as the unit under test, UUT. We're calling it up by its name as a half adder, and then we're mapping the signals to the ports of the component. So remembering the signals are part of the test bench, the ports are part of the component. So you can see this, we've got this port map definition here where we're mapping signal to port. So because we've named them the same thing, signals and ports have the same names, they just have the same names on both sides. Okay, and then the next part is where we're going to start exercising the signals, so changing their values and seeing what happens on our waveform graphing process. So this comes under a process called stimulus. So that's what we've defined there. And then we're going to begin that process by initially waiting for 10 nanoseconds, setting A to a value of 1. So A is one of our inputs. Waiting for 10 seconds, setting A to a value of 0. Of course, remembering that A and B both started off as 0. So essentially just exercising each signal one at a time for all possible different combinations that you can get. And then we will look at our output on the waveform graphing tool to see whether that did what we expected. then you always need an end process and an end of the entire test bench. Right, so I think that looks okay, so we can save and close that. Don't forget to save, because if you don't save, it will be working on the old version, regardless of whether you've made changes or not. And then you can see here we still have the question mark because we haven't compiled this. So it's probably a good idea to compile it before we go to simulating anything. So if we just click compile here, or you can right click compile, compile selected. We only want that to compile that one, the other one's already ticked. And then here down at the bottom, you'll see there's a message, compile of test bench VHDL was successful. VHD was successful. If there are errors, they will appear in this control or command window here. You can click on them, as I've showed you in the previous video, find where they are and correct them. Save again and recompile. So now we want to test our circuit. So there's a few different ways we can do that. We can go into the simulate command here, and we can go start simulation, or we can right click on here. Oh, sorry, you can't right click on there. I thought you could. Oh yes, you can change this menu here to simulate. But we'll do it by just doing the simple way. Simulate, start simulation, and it will ask you what you want to simulate. So we've been working in this work directory, so we want to open that up, and the thing we want to test is this test bench here. Okay, I did have a previous one called Added Test, but I deleted that, but you can see it's still in the menu there. Just ignore that, but what we want to test is this test bench. So we can just click OK on that, and you will see some commands coming up in the command window down here showing you what's going on. If it's finished simulating, it will come up with a message like this, VSim2. Or common problem is it refuses to do this. It gives you some quite weird messages, and it's because your license either doesn't match the download of your program or is in the wrong folder. If that happens, the best thing to do, well, if it's a simple thing of being in the wrong folder, the first video I did showed you how to change that, where to put it, so you could just move it. If it's because the license doesn't match the program, the only thing you can do is uninstall the entire program, go back to the ModelSim web page, download the program again, and obtain a new license. Okay. I had problems with this, and I had problems with the licensing, and that was because I wasn't logged in as an administrator. So that's another thing you do need to be careful and make sure you're logged in as an administrator. Right, so if we want to test this, we do need this objects window here. If this objects window doesn't appear, you can quite quickly change it by clicking View Objects. And the other window we probably want is the wave window. So I have my wave window undocked. You probably, when you bring yours up, it will be docked. You can easily undock it with this little icon here which says Dock Undock. Looks like a little square with an arrow coming out of it. Okay, so we've no signals showing on this waveform viewer. Oops. Yeah, so I did show you how to open that, I think, didn't I? Just select View Wave. So we've no signals here, so what we want to do is we want to drag our signals from our objects into our waveform viewer. So you just highlight them. Oh, need to see both windows at the same time there, which isn't so easy. Right, highlight them. No, it's not going to let me do that. It might let me copy and paste. Let me try that. Oh, it doesn't let me paste. I didn't have this problem last time. I'll tell you what we'll do, just do that. Yeah, that'll make it easier. There we go. So it's easier to just drag them. So if we just go there, there, there and there, drag them across, and they appear. Okay, now you can see, if we go back to this one, looking at the waveform viewer, we can see there's no signals shown because we haven't actually run the simulation yet, and we've also got the initial states of the 4 signals here. So the 2 inputs are at 0 because we initialized them in our VHDL code. The 2 outputs are unknown because we haven't yet run the simulation. So the next thing you want to do is set up your time here for the amount of time you want it to run. So if you'll remember, our test bench would have 10 nanoseconds delays between each change, so probably 100 nanoseconds in this case is quite acceptable. And then the last thing you do is just click Run here. And you can see very quickly it simulates the circuit. So we can't see that very clearly, it's a bit small. We've got typical zoom and not zoom. So if we just zoom in, that's fine. We can also move the signals around. I think if you just click on them, you can move them up and down. You can add signals, you can try that for yourself, but if you've dragged everything in, you won't really need to change that. So if we just zoom out a bit so we can see all the different options we have here. Yeah, I've zoomed in a bit too far. So there is a scroll bar at the bottom here for moving around as well, but I'm just going to zoom out so we can see the whole test in one without having to scroll. So we can see if we have A and B 0, sum and carry are 0. In fact, let's add a cursor. So there's cursors here. If we just click add a cursor, you can move this cursor along, and wherever that lands, it will tell you here what the value of those signals are. So just going back to the beginning, if we go right down to here, we had 0, 0, we get nothing out, and we get no carry out. The next one we've done is 1, 0, so we would expect to get a 1 on our sum, which we have indeed got, and a 0 on our carry, which we've got. Carrying on here, this is another 0, 0, so again 0, 0. Here we go, we've got 0, 1, so again 1 on the sum, 0 on the carry, 1 on the sum, 0 on the carry, and so on. Like go through the end here. Here we've got 1, 1. So here we would expect to have 0 on the sum, which we have on the waveform, and 1 on the carry, which we have on the waveform, and you can see that here as well. And that's really all you need to know. You could, I suppose, take a screenshot of this for your reports. Now, do try your best to get at least some simulation done, either with the EDA Playground online simulator or with this ModelSim simulator. If you've tried for hours and hours, you've phoned the help desk, you've contacted me, and you still can't get anything to work, I will accept in your coursework drawn waveforms. So you can sketch the waveforms that you expect out, but that's very much a last resort if you really can't get anything else to work. If you miss out the waveforms altogether, you'll get no marks for that particular part. So the rubric will quite clearly show you that you'll lose marks there. Okay, that's all for today then. So I'll just leave you with that and you can have a play around. It does look a very complex simulator, but don't worry about that. The things I've showed you are all you should really need to have to do. Okay, bye for now.